So the main goal of topic number 4 is for us to trade in between descriptions of a linear relationship in graphical format. So in other words, looking at a picture that depicts a linear relationship, in other words, a graph. Trading back and forth between that and a numerical or a data table view of what that relationship looks like. But then, of course, at the top of that heap is also an equation that describes that relationship. And I like to think of the data table as our bridge in between those two things. So in between the graphical and the formula, the algebraic realization of a linear relationship, we're going to take a pit stop, but it's an important pit stop at the level of a data table. So that's where I want to start, actually, talking about this, because without a data table, I'm not going to get very far in this problem. So the question here asks us to find an equation which describes this line. So the first thing I'm going to do, actually, is from this line, what I need to do is extract some data points. I want to know what are some examples of some ordered pairs x, y whose points actually lie on this line. So if you can see this grid clearly enough to say, give me an example of one point which lies on this line that we can read off the graph for sure.
0 minus 3.
Yeah. So to me, this would be the first place that my eyes go, because the point at which this line crosses the y-axis happens to be right there on a whole, what looks like a whole number. So we'll use that as one of our data points. X equals 0, y equals -3. One of the other benefits to choosing that as our point is that it also immediately tells us what the y-intercept of this line is going to be. What is the y-intercept of this line, given what we just said? Remembering that the y-intercept is, by definition, the y-coordinate of the point where this line crosses the y-axis. So it's -3. That knowledge comes in really handy if we're going to write a slope-intercept equation for this line, because now we have the intercept part of the slope-intercept form staring at us right in the face. Again, if we believe that -3 is exactly the point where this crosses the axis, and I think we have to believe that because this is the information that we're given. So we're just given a graph, so we have to trust our eyes in this problem. But one point is not enough to get us to where we're going. Before we find an equation for this line, we really do need a second point. So can anyone see another point that might be convenient to use from this graph that can help us to find an equation?
Minus 2a.
Yeah, so I also see, if I go all the way out from 0 out to 8 on the x-axis, then the y-coordinate of that point is -2. It's always convenient, really in any kind of algebra problem, to try and use whole numbers wherever we can. So my eyes, when I look at this graph, are just scanning to look for a place where the graph crosses the integer lattice. In other words, where it actually crosses the graph paper at an intersection point. And so here the x-coordinate is 8, the y-coordinate is -2. And that's going to give me a second point. The only other place I see on this graph where that happens is over here in the lower left. Right? Over here, the point -8, comma -4. We could also have used that point if we want. Ultimately, the answer that we get to this question should not depend on which point we chose, which 2 points, rather, that we chose. So we don't have to care about which of these we choose. As long as we do the rest of the work correctly, we're going to get the right answer. So this is my intermediate step. This is my safe haven. I take from my graph and extract what information I can from the graph, which is I'm just going to find 3 points. Really only need 2, but I'm going to do 3 just for fun. And now from this, we're going to determine our equation. So if I want now to find, let's start with a slope-intercept equation for this line. And when you hear the words slope-intercept equation, what template, what kind of equation does that make you think of? What does a slope-intercept equation look like? Yeah, that's the most popular equation template for students of algebra. Y equals mx plus b. Where the role of b here is played by what? What does b signify? The y-intercept. And we just happen to know that our y-intercept is negative 3. So this is actually a pretty convenient problem to use slope-intercept form for. So let's just write that y-intercept right in to our work as we're working on this. Whoops. Make some room for ourselves here. So for y equals mx plus b, we're convinced that the y-intercept of this line is negative 3, so we're just going to write that in as ib. So the only thing we don't know is the value of m. And now where do we get m from? What role does m play in the slope-intercept equation?
Rise over run.
Yeah, it's our slope, exactly, which we find by dividing a rise and a run. So there, we need to compute. Now, what is the slope of this line? And that's the kind of information that we need to get out of a data table, right? We don't know how much this line is rising or running except by comparing, respectively, its y-coordinates and its x-coordinates. Specifically, the distances, the differences in the y-coordinates with the differences in the x-coordinates. So for that, how do I compute rise over run? What do I actually end up having to do?
And do y2 minus y1 over x2.
Yeah.
minus x2.
Yep, this is the formula that most people remember as the slope formula, y2 minus y1 over x2 minus x1. I'm going to color code this really quickly. y2 minus y1 over x2 minus x1. So I need to subtract and then divide. And I can use any pair of points that I like to for this. So maybe let's choose this pair, 0, negative 3, and 8, negative 2. So my red point and my blue point. So first, if I do y2 minus y1, what am I really subtracting there? y2 is the y-coordinate of my second point. y1 is the y-coordinate of my first point. So what I really am doing is negative 2 minus negative 3. And immediately you can see how there's a potential to make sign errors in computing a slope. And I know for a few of you, I was corresponding with over email as you were working on the homework problem. You're like, why is my slope wrong? Well, you made a sign error up there. Or at least if you're going to make a sign error, make it the same way in both numerator and denominator so the sign errors cancel out. That's, if you can manage to do it that way. Better just to avoid them altogether. So what is negative 2 minus negative 3? Yeah, remember it's the same as negative 2 plus positive 3, right? And negative 2 plus positive 3 is positive 1. And so the interpretation of that positive 1, by the way, is it's the amount of difference that there is in between these two y-coordinates, right? The y-coordinate of my first point and the y-coordinate of my second point. You can check negative 3 plus 1 gives me negative 2. So in the data table, that's where these rises and runs show up. So now all we need to do is the same thing, but for my x-coordinates. So here, x2 is the x-coordinate of my second point. x1 is the x-coordinate of my first point. So if I do x2 minus x1, it's going to be 8 minus 0. And that's a difference that's a lot easier to navigate than the other one we just did. That's a difference of 8. And again, that shows up as the difference in between these two x-coordinates. 0 plus 8 gives me 8. And so my rise was 1, my run was 8, and if I divide the two of them, I get my slope. So the slope of this linear equation is 1/8. So what's my last step? What do I have to do? Now that we know what our slope is, we just have to drop it in. And then we are done. So it turned out to be really powerful in this problem that we knew what the y-intercept was right out of the chute, because we didn't have to do any extra work to find what b is. Let's enter this equation into WebWork, just into this practice problem and just verify that it works, and then we're going to go back and look at a different approach. In this problem, we were really lucky to be able to know what the y-intercept was right at the beginning. But we're usually, I would say, not so lucky. So let's imagine for a moment that we didn't know that red point. Let's take it out of the running altogether. What we're going to see next is just a refresher of a quick, well, it's sort of quick, I mean, I kind of like it, a way of still finding an equation for this relationship, just using a different strategy called the point-slope strategy. So this approach is going to work regardless of whether we know the y-intercept in the beginning or not. So we're going to treat this problem as though all we have are these 2 points, -8, -4, and 8, -2. So here, the first thing that we're going to do is find the slope, which, as always, is the same process of subtracting y2 minus y1. So now that's going to be -2 minus -4. Double check for me that that's +2. And then x2 minus x1. That's 8 minus -8. Again, double check me that that's +16. And then my slope is the ratio of rise to run. That's 2/16, but 2/16 is another name for 1/8. So we still got the same slope, even though we used 2 different points this time than we did last time. But now the difference is, if we don't know the y-intercept, we're not done yet. So now, instead of using the slope-intercept formulation, we're going to use something different. We're going to use the point-slope form. And for that, what we use is we just use a different template. Instead of using y equals mx plus b, in point-slope form, we use a different pattern. So it still has the y equals mx plus b type of form, except that now, instead of requiring us to know the y-intercept, what it requires us to know really is any other point. We'll call it x1, y1. Any other point at all. And if I know any other point at all, then the point-slope form just has me subtract that x-coordinate from my x variable and that y-coordinate from my y variable. So this is what we call the point-slope formulation. The role of m here is still the same as it was before. M represents the slope, which now we know what the slope is for our problem, 1/8. So I'm just going to drop that slope right into my point-slope equation over here. My y and my x are part of the equation template, so they remain y and x in my equation. But now what I end up plugging in is I plug in the coordinates x1, y1 of any point on this line that we happen to know. So I could use the blue point, I could use the purple point, it doesn't matter. Again, as long as my slope is correct, it doesn't matter which point I choose. So let me choose the one with fewer negative signs in it. I'll choose 8, -2. So I'll plug in an 8 for my x-coordinate right here. And I'll plug in a -2 for my y-coordinate over here. And this is another place to make a sign error. On the point-slope form, it's y minus the y-coordinate. So what I need to do over here is subtract -2. And subtracting -2 is, of course, the same as adding 2. So y plus 2 equals 1/8 times x minus 8. And that's what we might call a point-slope equation for this line. But here's the good news. And I guess it's good news. You might disagree. Feel free to disagree. But the good news is that this is not a different equation from the one that we found when we did it in the slope-intercept format. Because if we were to simplify it, I would distribute this multiplication across this subtraction, giving me 1/8 x minus 1/8 times 8. 1/8 times 8 is 1. And then if I were to want to get the y by itself, I would need to subtract 2 from both sides. And when I subtract -1 minus 2, I'm going to get -3. Which, lo and behold, that's the equation that we had in slope-intercept form the first time that we found it. So there's not really a different result in looking for a slope-intercept equation versus a point-slope equation. It's just kind of a difference in the process of how we get there. You can use point-slope at any time, regardless of what information that you have about a line. You can always use point-slope format to get it. It's just a matter of, do you then want to simplify it down to get the slope-intercept version of it, or can you just leave it as it is? From my perspective, unless a question specifically asks you, as the original one did here, unless it specifically asks you for slope-intercept, I am personally okay if you just left your answer in point-slope form, if that's the way that you're doing it. I think the most salient part of this process is actually the computation of the slope to begin with. If you've got that, then you've got most of what you need anyway, and that's just a matter of how do you present your results.